Alrighty, we are looking at geometric series in this video. So sums of geometric sequences. Let's get started with our objectives. They are to find the sum of a geometric series, to apply the formulas for the sum of a geometric sequence to solve problems, to determine whether an infinite geometric series converges, and to find its sum if it does, and to apply the formula for the future value of an annuity. So we're going to look at what an annuity is. That might be a new term to some of you all. All right, so our first definition, a geometric series is the sum of the terms of a geometric sequence. That makes sense, knowing what a series is and then classifying it as geometric. So if you're working with a geometric series, the sum of the first n terms of a sequence having a common ratio of r is either this first formula or the second. And you'll use them depending on what you're given. Notice that the second formula requires that you know a sub n, or the nth term in your sequence, so the last term that you would be adding. Let's use these in this first example. We're going to find the sum of the first 10 terms in this geometric sequence. So to be able to do that, we need to identify some key characteristics of our series. We need to know our first term, and really it would be kind of counterintuitive to try and find all like the 10 terms that we were going to add. So the last thing that we need to know is our rate. That would be your second term divided by your first. Or, because since we're working with fractions, you can multiply by the reciprocal. We're working with a rate of 3/2. Oh yes, and we're adding up to position 10. Now we'll substitute into that first formula. And notice that I've expressed 3/2 as a decimal. That might be easier to work with when you're plugging it into your calculator. And why don't you pause this video right now and see how you do plugging that into your calculator. I would find the numerator and the denominator separately and then work that quotient. So pause this video and try and do that right now. All right, you should have just about, when you round, 566.65 as your sum. All right. Now we want to find A3, our third term in our sequence, given that it has a rate of 2 and the sum of the first 6 terms is 189. All right, so since we're working with a sum, we're given the sum, we're going to need to use our sum formula to find our third term. Just kind of brainstorm right here for a moment. What would you have to do to be able to find that third term? Just kind of think about it for a little bit here. What we need to do is find our first term, and then it would be really easy to use your rate to find the second and then the third term. So we're going to try and solve for A1 using this formula. So we'll just substitute in, and then you can simplify that numerator and the denominator. You'd really just be dividing by a -1, so you'll notice that that will change the value there. You can check that math on the side. Then you divide each by 63, and that gives you that your first term is 3. So just applying the explicit formula, that would be 3 times your rate of 2 to the 3 minus 1. That 3 right there, that's being multiplied by the 2, that is your A1. That's from your explicit formula. So you'll have 12 as your value for your third term. And you could have just taken 3 and multiplied it by 2, which gives you 6, and then multiplied it by 2, which would give you 12. I just am really familiar with the formulas, so I used those real quick. Okay. So here, I really like this example because it is something that can really benefit you, I think, knowing these kind of payment options. So you have the opportunity to be a golf caddy, and he is going to hire you, and you get to choose how you want to be paid. You can either be paid the first $1 for the first hole, $2 for the second hole, and in that manner, such that then on the 18th hole he'll pay you $18. Or you can be paid 1 cent for the first hole and double that every hole thereafter. And so we have to select, okay, well, which one do you want? Which payment option are you going to take? So looking at that first, the first hole, you'll be paid $1. Second hole, $2. Third hole, it would be $3. Fourth hole, $4. So you should recognize that it's just increasing by 1. You're just adding 1. So that makes it an arithmetic series. And you could find the sum, you could find your total by using that sum formula. Now what's really cool here is we know our first term is $1 and our last term would be $18. We're adding a total of 18 terms. So that's your in position. Take a moment to figure out that total using your calculator. Just pause this video right quick. You would earn $171. And yeah, so that seems like a decent amount of money. I guess it would kind of depend on how many hours you're out there and how much you like being in the sun. Now, the next one, each time that you're paid, it's double. So you're multiplying by this rate, by this doubling rate. That is a geometric series, and we're going to use our sum formula to find out what would be your total cost. Your total payment when you go up to 18 positions, because there's 18 holes. We don't know the last term, so we'll just use only the rate, which is 2 because you're doubling. And on the first hole, that first position, it's 1 cent, which is expressed as 0.01. So take a moment to find that total in your calculator. All right, did you see that coming? This is a perfect showcase of the power, the growth that happens with geometric sequences. It's actually exponential. And if you remember the graphs of exponential functions, they grew crazy fast. And it wasn't just a constant increase. After a certain period of time, it just looked like it was going straight up, almost vertical. That is what we're working with here. This is quite a wonderful growth model if your payment is going to be modeled as such. So I would, of course, choose this one because then I could invest that money and be able to golf in my old age. All right, so I'm going to pause this video here. I'm going to end this video here, and we're going to do part 2 in a next video. So stay tuned for that.